So welcome back. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cyber Security Department, MLR Institute of Technology, Hyderabad, as part of a data mining video lecture series. And today in this lecture, we are going to discuss a concept called as a data cleaning as a process in data pre-processing. So mainly we are going to discuss how we can see this data cleaning as a process. The first step in this data cleaning as a process is a discrepancy detection, that is mainly to find out the noise and to find the outliers and also the unusual values that need some investigation. So discrepancy varies, that is in different forms. Like the first one is the poorly designed data entry forms, so that may have the many optional fields. Next variety is the human error in the data entry, deliberate errors like respondents not winning or wanting to dialect the information about themselves, and data decay, that is outdated addresses, etc. And another form of this data discrepancy is inconsistent data representations and the inconsistent use of codes. So let us see some other forms of data discrepancies, like errors in the instrumentation devices, so that record the data, and system errors. There are two types of errors, like a system error and the data errors. And errors can also occur when the data are inadequately used for the purposes other than the originally intended. So our intention is the different, and the purpose of collecting the data would be the different. And another is data integration, mainly where the given attributes can have the different names in the different databases. For example, let us say in the database 1, a customer ID would be the attribute name of this customer ID, like customer underscore ID. In some other database, DB2, the same attribute would be renamed as customer ID. So both, we have to check whether both the names, like in this database DB1, the customer ID, and the second database DB2, the customer ID, both are representing the same attribute or not. So how we can proceed with the discrepancy detections? So we use whatever the knowledge we have regarding the properties of the data, like that is also called as metadata or data about data. Like suppose if you take example in this student table in Oracle database, that student table may have attributes like roll number, name, the CGPA, or some other like MSET rank, like. So these are the student data is a data, and the roll number, name, CGPA, MSET rank, these are the attributes of this data. And let us say, like suppose 10 MB, the file size, this is a file name, and the file size and the location. All this information comprises the metadata, that is the data about data. So we can use the knowledge like that metadata, that describes the properties of the data. Next, what are the data type and domain of each attribute? So then only we can check the discrepancies. So we should understand what are the data type and domain of each attribute. And next, what are the acceptable values for each attribute? So like for example, if you take a roll number, the roll number, there should be some format need to be followed. And the name, like suppose some 15 characters is the maximum length of name, and CGPA, and the format, and also the unset rank, or all this. So each attribute would accept the set of possible values. So we should understand what are the acceptable values for each attribute. And then statistical data descriptions, like that is mainly these are statistical data descriptions would be used to grasp the data trends and identify the anomalies. We already discussed in detail about the anomalies. In future also, in future lectures, we would also discuss about this anomaly. And this, the financial like a statistical data descriptions, that is mainly used to grasp the data and data trends and identify the anomalies. That is, for example, to find the mean, median, and the mode values. And we could also understand the data distribution. So the previous lecture also we have seen the how the data distribution would be like. Suppose if the data is following the log normal distribution or a normal distribution, and then you can see this, if you cut this image and the right side and this part both are looks like a symmetric, right? This part is would be the mirror image of this right side part. If the data distribution would look like this, if you plot on this two-dimensional, like suppose on this, and if the distribution would look like this bell-shaped curve, then we could say it is a normally distributed and it's a symmetric. Else if the data is skewed, whether it is a left skewed or a right skewed, that means the data distribution would have a long tail, either left or the right hand side. Like suppose if it is on the left hand side, the data distribution would be like this, and if it is on the right hand side, like suppose another skewness would also measure like this, and this is also a skewed data. So we have to check are the data distribution is a symmetric or skewed. Next, what are the range of values under that particular attribute? And we also check, do all the values fall within the expected range or not, and what is the standard deviation of each attribute. And another important thing is values that are more than the two standard deviations away from the mean. For example, and if you take the same like a normal distribution curve, let us say this is a mean, like the standard deviation, like suppose this is a 1 standard deviation and this is a 2 standard deviation. Similarly, and on the left side also we'll take the 1 standard deviation away, and this is the 2 standard deviation away. So here the standard deviations, mainly what are the data points and their means, their standard deviations are the 2 standard deviations are away from this. Like suppose, and this part of the data is 1 standard deviation away from the mean, and this part of the data, like suppose and this part of the data would be the 2 standard deviations away from the mean. So the distribution by using the standard deviation and mean, we could also understand the potential outliers in the data. Next, are there any known dependencies between the attributes? Like the correlation analysis could be done to understand the dependency among the attributes. So as a data analyst, you should be on the lookout for the inconsistent use of codes and the inconsistent data representations. For example, if you take the date, like here 2010, 12, 25, the same date would also be represented in this format like 25, 12, 20, 10. Like suppose if you take one best example of this kind, like 10, 9, 20, 24. So, and if this would be represented in one format and this is another format, like suppose this could be interpreted as so 10th September 2024, and the same could also be interpreted as 9th October 2024. So we have to handle this inconsistency. Our data should not have the inconsistent data because that leads to the inaccurate data. Next, the field overloading also need to be checked because this is another source of error, an error source that typically results when developers squeeze the new attribute definitions into unused portions of already defined attributes. For example, an unused bit of an attribute that has a value range that uses only like say 31 out of 32. So the data should also be examined regarding the unique rules, consecutive rules and null rules. So what the unique rule says? The unique rule says that each value of the given attribute must be different from all other values for that attribute. So for example, like in database management system, while creating the tables, we define the attribute as a unique so that it will not allow you to enter the duplicate values under that particular attribute. And next rule is a consecutive rule. The consecutive rule says that there can be no missing values between the lowest and the highest values for the attributes, and that all values must also be unique. Next rule, that is a null rule, that says the use of blanks, question marks, special characters or other strings that may indicate the null conditions. For example, whether a value for a given attribute is not available and how such value should be handled, right? If suppose if there is nothing, so there is no information to fill that particular field, so then how that information need to be represented. So we should understand. So this null rule says that what are the standards need to be followed or how to handle such values. For example, like us to store the 0 for the numeric attributes, a blank for the character attributes, or any other conventions that may be used, like entries like don't know or the question marks, and these need to be transformed to the blanks. So there are some other commercial tools that help us in finding the detecting the discrepancies. One among those is the data scrubbing tools. These data scrubbing tools are used in a simple simple domain knowledge. For example, like postal addresses and spell checkings, that is to check the errors and make the corrections in the data. So these tools like data scrubbing tools mainly rely on the parsing and fuzzy matching techniques and cleaning the data from multiple sources. Next, another commercial tool that is can aid in the discrepancy detection is a data auditing tool. That is to find the discrepancies by analyzing the data to discover the rules and relationships. Just now we discussed the 3 rules, like a null rule, unique and unique rules. So this, by using these auditing tools, so we can analyze the data to discover the rules and the relationships and detect the data that violate any such conditions or the rules. For example, so they may employ the statistical analysis to find the correlations or clustering to identify the outliers. So data discrepancy detection would also comprises data migration tools. Migration tools also used to detect the data discrepancy. These data migration tools allow simply the transformations to be specified, that is to replace the string like a gender by the sex, and that is in the ETL, extraction transformation tools. And these tools allows the users to specify the transforms through a graphical user interface. Like suppose if you check this ab initio, it is one of the ETL, extraction transformation tool, like Informatica, some other tools in the in the industry. And this is a graphical user interface. And on the right hand side you can see, and let me take another color. So you can see on the right hand side, so we have the set of like the components. You can see like a sort component, the join component, like normalize component, reformat, roll up, scan. These are the different components. So here we can simply drag and drop these components to the build the process by using these components. So here you can see this a simple job, that is to do this ETL, extraction transformation and loading. So here you can see there are the different data sources like a customers, transactions and the customer information, and these data being transformed. Like here you can see the join and the household. The transformation is applied and the reformat transformation is applied at this point, and rejected records will be diverted to this database, and this transformation will be used to remove the duplicate households. And again we use the join component to join all these three inputs, and then the output of this join, and again we use the select component so to select the specific records and keep in this output file. So for example you can see, let me erase this part. So this is one simple job that is designed by using this ab initio GUI. Here you can see the customer data file we have, and we applied the sort transformation technique, and this is another component that is used to identify the duplicates, so that the duplicates, once it identifies the duplicates, those duplicate records will be diverted to the another database, and then the rest. So these are the examples to understand much how the graphical user interface of this ETL. So these tools typically support only a restricted set of transformations, so that we can also choose to write the custom transcripts for this step of the data cleaning process, because we have a very typical restricted set of transformations. If you want more, and if the tasks need to be done, so that we can write our own scripts for the data cleaning process. And if you see this data cleaning as a two-step process, that is a discrepancy detection and the data transformation. However, it is a error prone and a time consuming process. The data cleaning would be, if you see it as a two-step process like a discrepancy detection and data transformation, it would be error prone and a time consuming process. Some transformations may introduce the more discrepancies. We'll discuss it in next lecture in detail. Some nested discrepancies may also be detected after others have been fixed. Like in order to resolve the next set of discrepancies, so we have to resolve some other discrepancies. So that is the way the nested discrepancies may be handled in this data cleaning process. So if you could summarize what we had discussed in this lecture. So we discussed how we can see this data cleaning as a process. Data cleaning as a process, mainly how we can detect discrepancies. There are, like we discussed, the different types of discrepancies, and also the different rules among these, and some statistical methods and commercial tools, etc. So next lecture we will discuss about a data integration technique. Thank you all for watching this.